Hello, my dear students. Welcome back to the lecture. In this lecture, we will see what are the different grades of concrete, and also we'll try to see what are the different grades of cement we have, and we'll try to see what are different diameters of the rebar that is available in the market, which will set all the basics for us, which is required to continue with the course. Now, coming to this, the basics of civil engineering, we'll see what are the different grades of concrete. We understood what is concrete. Now we'll try to see what are the different grades of concrete. So before that, now let us say there's some 60 kg of a load which is kept in front of me. And if you ask me to pick it up, I can easily pick it up. So that is my capacity. So you may pick up like 70 or 80 or 90 kg of the load based on your capacity. There may be few other people who can pick max to max 40 kg of the load. Above 40, if you ask them to pick, it's quite difficult for them. So that is their capacity. In the same way, when we put any structure, concrete structure, it will have certain capacity, and it depends on the grade of a concrete, what exactly grade you're preparing. So we'll try to see that. So we have M7.5 grade of a concrete. Forget about this number, that is 1:4:8. We'll come back to that later. Then we have M10 grade of a concrete. We have even forget this thing. We have M15 grade of concrete. We have M20 grade of concrete. We have M25 grade of concrete. Beyond M25, we have like M30, M35, M40, we have grades up to M100. But usually in the most of the construction practices, we usually start with M20 grade of concrete, normal structure. Again, depends on the conditions. You can make use of M25, M30, 35, 40 based on the requirements. We'll not try to get into that. Just understand we have grade up to M100 also. Okay. Yeah. Now, first we'll understand what is this letter M indicates. And we'll try to say what is this number 7.5, 10, 15 indicates. Let me write it here. So the letter M indicates mix, whereas the number like 7.5, number like 10, 15, and 20 and 25, they indicates the characteristic compressive strength of the concrete. Just remember that. It's quite a big sentence, but that's how you have to remember. Characteristic compressive strength of the concrete, right? So this much is understood. Now we'll try to see what is this number 148 indicate. What is this number 136 indicates? Now first always remember the first number what is shown here, no, that is 1, 1, 1, 1 and 1. They represent cement. The second number like 4, 3, 2, 1.5 and 1. They indicate the amount of sand, that is a fine aggregate. And the last number like 8, 6, 4, 3 and 2, they indicate the amount of coarse aggregate. Now let us say I told what is concrete. It's a mixture of coarse aggregate, fine aggregate, cement, add water to that, your concrete is ready. Now if I tell you prepare a M20 grade of concrete, then how you are going to prepare it? Of course you will use cement, sand and coarse aggregate, but how much proportion you need to mix, that you don't know. So that is what it's indicating. If you want to prepare M20 grade of a concrete, you have to mix your proportions. You have to proportions the ingredients like coarse aggregate, fine aggregate and cement in the ratio of 1:1.5:3. So how exactly you're going to do? Just concentrate here. What exactly this, what do you mean by this? Now if I put it in a very simple way, he has taken a cement here and it is on a shovel. Shovel is a tool where we have taken a cement. So how many shovel you can see? 1. So can I write one part of shovel was taken here? I'll write it here 1. Okay, done. Next, look here, how much sand is taken? 1 and 2. So 2 parts of sand was taken. I'll write it here as 2. Now look here, look at the aggregate 1, 2 and 3. That means 3 parts of coarse aggregate was taken. I'll write it here 1:2:3. So this is how we have to do. Okay, I hope this much things are clear. Yeah. Now let me erase everything. I hope your fundamentals are clear up to here, right? Yeah. So now the question is that why there are so much grades of concrete? Why is that we couldn't have kept only one grade of concrete? Let us say M15 done. Why is that we have 15, 20, 25 and all? So based, like I mentioned, based on the requirement of your structure, we have taken different grades of concrete, but just concentrate here, the M7.5, M10 and M15. We call this particular concrete as lean mix, or usually we use them in the PCC. Now what is PCC? PCC stands for plain cement concrete. We'll try to understand this in the due course of a time, what exactly PCC is. As of now, try to understand PCC stand for plain cement concrete. So whenever you want to do some inferior quality of a work, that means normally if you want to put some bed concrete and all, in that case we can go with this grade of concrete like M7.5, 10 or M15. But when you put RCC structures, like you're putting a concreting for the footing, for the column you're doing, for the beams you're doing, for the slabs you're doing, retaining wall or water tank, whatever may be, in that case, our IS code book says that, that is Indian Standard 456 2000 code book says that minimum you have to use M20 grade of concrete, right? So if somebody asks you what is a minimum grade that you're supposed to use in a structure, it has to be M20. That is a minimum. You can use M25, 30, 35 based on the requirement of your structure, but M20 has to be the minimum grade. Okay, so that is why we are bifurcating all these different grades of the concrete. Yeah, so this M20, M25, we call this as a rich mix. This is called as lean mix, and this is called as rich mix. Why it is called as rich mix and why this is called as lean mix? If you observe it carefully, in the M7.5, you can see 1:4:8. That means 1 part of cement, 4 part of sand, and 8 part of coarse aggregate. That means the coarse aggregate content is more because it's 8 part, right? When I say 1:4:8, I'll take 1 part of cement, done. And it is 4 mentioned here. I'll take 1, 2, 3, and 4. 4 parts of sand, and it's written 8 parts. So I'll take 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 parts of coarse aggregate. So here the amount of coarse aggregate is more. So hence this particular mix will become lean mix. Lean in the sense the cement quantity is very less than, but whereas the coarse aggregate quantity is more. So it becomes a lean. Lean is a very rough mix. But if you observe to M25, if you come to M20 and M25, see here, it is 1:1.5:3. That is 1 part of cement, 1.5, that is 1 part I'll put sand, then another half I'm going to take 1.5, and 3 parts. So 1, 2, and 3. 3 part of coarse aggregate. Now, in comparison to M7.5, this is a bit richer mix, because here the coarse aggregate content is like, here it was 8 parts, here it is only 3 parts. But if you come to M25, you see here, it is 1:1:8. 1 part of cement, 1 part of sand, and 2 parts of coarse aggregate. So it's a richer mix. So that is a difference. So that is why we have written it as lean mix and richer mix. Here your cement quantity will be more, right? So there will be a good binding. Whereas here your cement quantity will be very less, because since you're putting a lot of coarse aggregate, all the coarse aggregate, there will be a lot of voids. Voids in the sense, in between two aggregate, there will be voids, and all the voids will be filled by this cement paste. So you will not have any cement paste to lubricate. That means there is no more amount of cement paste. Whereas here, since your aggregate quantity itself is less, the voids will be less. If voids are less, then less amount of cement paste will go in filling the voids. If less amount of cement paste goes in filling the voids, more amount of cement paste will be there for the lubricating, right? So that is why this is called as a rich mix, and this is called as lean mix, right? I hope up to here your fundamentals are clear. Next, we'll go to grades of cement. Now coming to the grades of cement, now we were discussing grades of concrete. Coming to the grades of cement, we have OPC 33 grade cement, we have OPC 43 grade of cement, and we have OPC 53 grade of cement. What is this OPC? So OPC stand for ordinary, OPC. Yeah. So it is called ordinary Portland cement. So the word Portland is a place where the color of that stone was first observed. So hence we have given the name as Portland. So it's a cement. We have kept the name as ordinary Portland cement. Okay. Now what does this 33, 43, and 53 indicates? In the same way, I didn't explain you what is this 7.5, 10, 15. How do you measure that 7.5, 10, 15, 20? And how do you measure this 33, 43, and 53? So for both of this, the answer remains the same. This is a concrete. So what we do usually, all these things are explained in my concrete technology course in a more detailed way. I've explained you. Here is quite difficult for me to explain each and everything. So that is why whatever is important pertaining to this particular lecture, I'm explaining you, right? So we'll understand what is this 7.5, 10, 15, how do you get that number? So usually, whenever we want to prepare a concrete, first I'll speak for the concrete. We have certain cubes. So this is called as a cube for me. Now let us say I want to prepare M20 grade of concrete. So we know that for M20 grade of concrete, we know for M20 grade of concrete, what is the ratio? It is 1:1.5:3. That means I need 1 part of cement, 1.5 part of sand, and 3 parts of coarse aggregate. I'll take that much part. I'll add water to that, and I'll prepare the concrete. And once I prepare the concrete, I fill that concrete in this particular mold. So in this particular mold, I'm going to fill that particular concrete. After that, next day, that is now, right now it is 3:30 p.m. Tomorrow 3:30 p.m. in the evening, I'll demold it. Demold in the sense I'll remove this mold, so that what will happen, you'll get this particular cube. We'll get a cube something like this. Then I'm going to place this particular cube in the water. That is called as curing, right? I'm going to do the curing of my cube mold for 28 days. Now, one question that may come in your mind. So why is that only, why you are doing it for 28 days? Because it has been found through experience. It has been found through research. The concrete is going to gain that complete strength. What is that complete strength? This M20 means it has to gain 20 Newton per mm square strength. So this 20 Newton per mm square strength will be gained only at the end of 28 days. So that is why we are supposed to do the curing till 28 days. Curing in the sense, you will take this cube. I'll show it here. You're going to place it in the water tank. So this is your water tank. You're going to place it in this water tank for 28 days. And after 28 days, you're taking the cube out. And then we are going to load that into this compressive testing machine. You can see your cube here. And this is my compressive testing machine. And in this compressive testing machine, I'll apply the load on that. I'll apply the load on that. And at one particular load, this cube is going to fail. So once it fails, this is how the failure pattern will happen. You can see it has failed here, right? So when that failure happens, this is called as dial gauge. So this dial gauge will show you certain reading. That particular reading is a load at which this particular cube has failed. So now from simple mathematics, that is, we know that stress is equal to force upon area. I'll write it here. Stress is equal to force. So force, or I can say load upon, let me write in this way. Yeah, force upon area. Okay, so I know I want to find the stress, that is 20 Newton per mm square. Newton per mm square is a stress actually. Okay, that's a unit of a stress. So force I will come to know through this dial gauge. Area, how do you find? It's again very simple, because I know the size of my specimen is 150 mm by 150 mm by 150. Can I not find the area from here? If I multiply 150 into 150, 150 is my length and 150 is my breadth. If I multiply 150 by 150, it will come out to 22,500, I guess. Yeah. Okay. So I got the area. So multiply the force, multiply by the, take the force and divide it by the area, you'll get the stress. So in this way, we have to prepare 3 specimens, because with the help of 1 specimen, it's quite difficult to come to a conclusion, because concrete is not a homogeneous mixture. It's a heterogeneous mixture. Heterogeneous means it is made up of cement, it is made up of coarse aggregate, it is made up of sand. We are adding a water to that. So all these are the different materials. So with one particular testing, I cannot come to a conclusion and say this is a strength of this. So I'm taking an average of that. To take an average of that, I'll take 1, 2, and 3. I'll take 3 different specimens. For the same mix, I'll prepare 3 such specimens. Okay, and then I'll do a testing on all the 3 specimens, and I'll find the average value of that. And that average value, what you're getting, is called as characteristic compressive strength. And if I'm preparing it for M20 grade of concrete, I need to get the strength greater than 20 Newton per mm square at the end of 28 days. That is why I've written it as 7.5, 10, 15, 20, 25, 30, and so on, right? I hope you got an idea. Now, the same test we are going to do for the cement also. Right now, I was speaking for the concrete. Even in the cement, I told you about 33 grade and all, right? So if you just observe it here, it is written 33, 43, and 53. How do you get this? Again, whatever procedure I explained you, same thing you have to do. Only the 2 changes are going to happen. So there, your size of a specimen is different. Here you have to make use of specimen which is having a size of 7.07 by 7.07 centimeter by 7.07 by 7.07 by 7.07. Okay, this is the size. So you can see 3 here, right? 3 sample, you'll fill it once here, second here, 3 here. So you'll take 3 specimen, and again same testing you have to do, provided here you are making use of only the cement and the sand, because you're doing the test on the cement. So we'll make use of only cement and sand in case of testing for the cement. If you're doing for the cube, that is for the concrete, then you have to make use of cement, sand, and aggregate. Of course, water we need to add. That is how it has to be done, right? So I hope you got an idea up to here. Yeah, right. So for that, I'll give you a small understanding how it has to be done. You can see it here, no? 7.06 mm by 7.06 centimeter by 7 point, it is centimeter. Okay, 7.06 by 7.06 by 7.06, that comes out to be 70.7 mm, 70.7 mm, and 70.7. This is 70, 70.7, and this is also 70.7 for the cement. Then you can see compressive strength of the concrete will be the maximum load divided by the top surface area. Top surface area, we get it from here, and then we have to follow this procedure. You can see it here, no? See, he has taken, since I mentioned you that we have to take 3 sample, you can see this is first sample, this is second sample, this is third sample, and this is a compressive stress, that is 37.04, 35.04, 38, and I've taken an average of this. Average I got 36.70. So in this way we have to do, and finally whatever answer you get, it should be more, right? If I'm doing for M25, how much strength should I get at the end of 20 days? I should get more than 25. It can be 26, it can be 27, it can be 28. We don't have issue with that, but it should not fall less than 25. If it is falling less than 25, that means the proportion what you added is not correct, or maybe you're not done proper curing. All these are the different reasons. But always remember, at the end of 28 days, I need to get a strength greater than the grade of that particular concrete, right? That is how you have to do this cube testing and all, right? So I hope you got an idea up to here. It's explained in my course in a more depth, but still I have tried my level best to explain it here. So because that is how our basics are going to, work for us in the upcoming lectures. Yeah, so this is clear up to here. Next we'll come to this part. Yeah, next we'll understand the different diameters of the rebar, right? Different grades of rebar. This was a rebar. For concrete, we had like M7.5, M10, M15, M20, 25. In the same way, this rebar, what you get in the market, no? Even this also has certain grades in that. So first is Fe250, where the letter Fe denotes that it is made up of iron. I'll write it here. Fe indicates it is made up of iron. Okay, so that is why it's written Fe. Okay, yeah. Then we have Fe415. Then we have Fe500. Then we have Fe550. We have Fe550D as well. We have where the letter D indicates a ductile. I'll come to this word ductile a bit later. Then we have Fe600 and we have Fe600D as well. We understood what is this Fe. It stands for iron. Now what is this 250, 415, 500, 550, 600 and all? So it indicates the minimum yield strength of the rebar in Newton per mm square. The number like 250, 415, 500, 550, 600, it indicates the minimum yield strength of the rebar. That means if I take this rebar and if I try to pull it, how much load this particular rebar can take Newton per mm square, that is the capacity of this rebar. If I say I want to make use of Fe500, 550 grade of steel, it can take 550 Newton per mm square of the tensile load which comes on this. Okay, so because why I'm saying the word tensile, because we know this is very strong in tension. That is why we are making use of this, right? So that is why the number indicates the tensile strength, that is the minimum yield strength of the rebar. Okay, now practically if you have seen it in the market or if you have seen in any construction site, this number what I've written, 250, 415, 500, it will be written here. You can see 500 is written here. You see 500D. D is called as ductile and ductile, right? Up to here our things are clear. Two things we did not understand. Why is this D written here? Usually when we do the earthquake resistant structure, that means if you're constructing your house or buildings in the earthquake zone, the code says that, which is that code? The Indian standard IS 13920 2016 is a code book what we have. This code book says that you have to make use of those bar where D is written. So this is called as ductile. So when earthquake comes, I want my building, to vibrate in the sense I want my building to be ductile in nature. It has to, what you call sway in this way, but there should not be a sudden collapse to that. So this way in my building will happen. Why is that? If earthquake comes, right, I don't want my building to suddenly collapse. It has to, sway in this way and then come to its original position when the intensity of the earthquake is going to come down. So this can happen only when we make use of this bar like ductile in nature. So these bars will have enough ductility in that. Even if you pull, they'll have enough ductility in that. So that is why the code says that. So now most of the people make use of this D only. Even if you go and ask in the market, give us Fe500 bar, they'll directly give you Fe500D only, and there's no much variation in the price. Okay, and it is, but main intention of using this D bar is wherever there's an earthquake zone, it will be mentioned. Otherwise, you can make use of FE 500. There is no issue with that, right? These things got clear, and we also understood FE 500, 550, 4 and 5. Another thing, right now in the market, at least in the Indian market, we don't have FE 250 bar available in the market. We don't even have FE 4 and 5 available in the market. Whatever is available in the market, we have FE 500, 550, 550, 600, 650. I don't know about 650. We have up to 600. 250 and 415 is not available because the tensile, because the minimum yield strength what we are getting, it is very less for us. So we usually get a 500 Newton per mm square is a minimum yield strength of the bar. So if you go to the market, usually you get a 500 written on that. This 4 and 5 and 250 we don't get it in the market, right? So this was all about the different grades of rebar and different grades of concrete. Now we'll try to understand one more part, right? Like I mentioned, it's written here 4 and 5, 500, 550 and so on. Now see, these are the different bar what is available in the market. Okay, we now coming to the main point. What are the different diameters of the bar? So I've taken a bar here, it has got certain diameter. Okay, so this is the diameter of that. So we have different diameters of the bar. We have 8 mm bar, we have 10 mm bar, we have 16 mm bar, we have 12 mm bar, we have 16, we have 20, 25, 32, even 36 is also available. So most of the construction, we start from 8 to 25. 32, 36 diameter bar we usually use in the construction of the heavy structures like, bridges, the tunnels, the metro construction and all, right? So these are the different diameters of the bar, and on the diameter of the bar, on the bar, all these things will be written. TMT is thermomechanically treated. It's a treatment what you give to the bar, and 550 to 550, 600, 4 and 5 are the different grades of the bar. And another thing is that whatever bar is available in the market, the entire length of one particular bar is 12 meter or 40 feet. That means what I'm trying to tell is, you can see this bar, isn't it? This is the entire length of one bar. Okay, so this entire length of one bar is how much? It is 12 meter. This is 12 meter or 40 feet. How did you get this 40 feet? It's very simple. See, all this conversion as a civil engineer, you should know. We know that 1 meter is equal to 3.28 feet. So how much is my meter? It is 12 meter. So 12 multiplied by 3.28. Try to do it manually. You'll get answer somewhere close to 39 point something. So I've taken it as 40 feet here. You should be knowing both the things from here. Yeah. Now, why is that it is only 12 meter? Why it is not 13 meter? So usually most of the time when these bars were manufactured, this is how the bar will be manufactured. If you see if you have gone to any of the place where this hardware shop where these bars are available, they are going to keep it. They're going to keep the bar somewhere like this. These bars will be kept in this way. You can see it in this way. They are going to bend. Okay, this is how the bar will be available in the market. This is the shape. Okay, they are going to give a small curve to that, and this is how it will be kept. And also, how do you carry this bar? These bars we usually carry with help of a truck. Now if I try to draw a truck here, okay, let me draw a small truck here. Yeah, so this is a small truck what I have drawn. Okay, so this truck what was available back those days, the length of the truck was like 6 meter. This is the capacity. This length was 6 meter. This is only 6 meter. Okay, but the bar available is 12 meter. That is why we bend the bar and we keep it in this way. That is why we are restricted the length to the 12 meter. That is the one reason. So that is why you can get in the market a 12 meter bar. Okay, 12 meter. If somebody asks you in terms of feet, you can say 40 feet. Yeah. So, and now coming to the different diameters and how do you find the area of the bar? See, like I mentioned, we have 8 mm, 10, 12, 16, 20, 25, 28 diameter of the bar is also available. But usually in the normal construction, we don't use it. Then we have 32, 36 and 40 diameters of the bar. How do you find the area of one single bar? We know this bar, it is circular in shape. So we know that from the mathematics. Area of circle is pi by 4 into d square. So pi divide by 4 into d square. In place of d, you put 8 mm here. So you do it manually, you'll get 50, somewhere close to 49. I have taken 50. In the same way, for the 10, how do you find pi? Pi is 3.142. I'll write it here. So this pi is 3.142. You divide this by 4. Whatever answer you get, no? So that answer, I'll write here, answer, you multiply that by d square. D in the sense, whatever diameter you want to find. If I want to find it for 10 mm, for 10 diameter bar, multiply this by d square. So 10 into 10. Suppose, okay, 10 into 10. Suppose if you want to do it for 12, 16, same procedure you have to adopt, and whatever answers I've written it here, the same answers you're going to get it here. Now coming to find the weight of the bar. Weight of the bar means, let us consider, this is 1 meter. Yeah, let us consider from here to here, this is 1 meter. So if I weigh, and this is, let me see what diameter of the bar is this. Yeah, this is 8 mm bar. Okay, all these things will be written here. Okay, if you can see, it will be written here. It's written 550 and it is written 8 mm bar. Yeah, now you can see it. See, it is 8 mm and it is 550. So let us say this length from here to here, it is 1 meter. And if I weigh this 8 mm bar of 1 meter length on a weighing machine, it's going to weight how much? It's going to weight 0.39 kg. Okay, 0.39 kg. Suppose if I take a 10 mm bar of 1 meter length, it's going to weight 0.615 kg. If I take a 12 mm bar of 1 meter length, it will weight 0.88 kg. So in this way, all these are the weight of my bar. How do you find it? The simple formula what you can apply is d square by 162.5. So it's a very raw formula. What is that? It's d square. I'll write here d square divided by 162.5. That means if I want to find the area of a 8 mm bar, if I want to find the area of 8 mm bar, how do I do it? 8 square. 8 square is 64. That is 8 into 8 is 64. And 64 you divide it by 162.5. You're going to get 0.39. So this is kg per meter. Per meter, this much is a weight. Now, what is the total length of your bar? It's a 12 meter bar. So 12 meter is a total length, 12 meter total length. So if I want to find the weight of a total 12 meter bar of 8 mm diameter, what is the total weight I'm going to get? Very simple, 0.39. You multiply this by 12. And if you do it, you're going to get the answer. Let me do it. 0.39 into 12. So 4.68. So 4.68 is kg, right? So if you take a 12 meter bar of 8 mm dia, and if you weigh it on the weighing machine, you're going to get 4.68 kg is the weight of that particular 12 meter 8 mm bar. So now why I'm trying to explain you all these things, why it is needed. Tomorrow, if you're working as a site engineer, you need to do bar bending schedule. Anyhow, I'll try to explain what exactly bar bending schedule is when I explain you the footing calculations. There you should be knowing how much steel you require on that particular footing, how much steel you require, because we require a steel for the construction, right? It's not that the moment you're doing it here, you will place the order for the steel. That cannot happen. You need to do all these calculations. And previously, even before the start of the project, you have to get all this rebar steel in your site. So that is why that is the place where all these things comes into play. So that is why I explained in the beginning of the course. So later when I try to explain you all those bar bending schedule, so it will be easy for you to understand, right? So I hope you understood the concepts up to here. We'll see you back in the next lecture. Thank you.